In today's lesson, we're going to be looking at National 5 and the magnitude of vectors again with no calculator, and this time we're going to be looking at exam standard questions, so it's building on the skills that we learned last time. Okay, so remember the magnitude of a vector is the length of the vector. Okay, and someone's drawn in the nice triangle for us there, and we can see that the magnitude there is it's on the hypotenuse. Okay, so to find the magnitude, we're going to do the square root of x squared plus y squared. So to find out the hypotenuse, we do a plus there, don't we? Okay. This one here, we've got a position vector that runs from O, the origin, up to the point P. So remember, the magnitude is the length of this line here. So using those numbers there, the vector P will be 2, 3, 5. Remember, that's a position vector. Position vectors start at the origin and go up to their point. So I've taken the coordinate, turned it into a vector. So to find the magnitude for vector P, we are using Pythagoras in 3 dimensions, and remember we're adding there, okay, so we would carry that on. Okay, so this one here has got some questions on it that show us different ways that the notation is used within National 5 Maths. So the first one we've got there is got vector A to B. Okay, so that would be a vector that starts at point A and goes to point B. Put in the lines on the side there to say that I'm going to be working out the magnitude. So minus 3 squared and 4 squared, and remember we're adding that because we are finding the length of the hypotenuse. So that first one there comes out as 5. Okay, so you can see it should be easy enough, okay, because we worked on these yesterday. Next one, we've got vector u. Now remember, we write it, when we handwrite it, we underline it. Okay, so there I've got vector u, but when I put the lines down the side, that says I'm going to work out the magnitude. So what have we got? We've got 3 numbers. 3, minus 2 and 4, all being squared and all being added together there. Okay, square root of 29, and I can't simplify that any further. Okay, now I have to rub that out, so pause it if you haven't got that down yet. Okay, this next question here, we've been given the coordinate for the point P. So I'm going to do the position vector, which would be 2 minus 6. Okay, so to get from the origin up to the point P, we go along to down 6. And also I'll do the position vector for Q, which is 0, 8, along nothing and up 8. Okay, now it says calculate, and you see the lines down the side, calculate the magnitude for P to Q. Now, I don't know what P to Q is yet, so I need to work that out. Now, to work out P to Q, I have to do little q, take away little, oops, P, don't know where I got R from. Okay, so I'm going to do Q, take away P, 0 take away 2. Now watch for this next bit because I need to do 8 take away minus 6. 8 take away minus 6 is 14. So the vector from P to Q is minus 2, 14. That now puts me in a position where I can now, right, there's my lines down the side there. Okay, I'm about to start working out my magnitude, the distance from P to Q there. Okay. Remember, a negative number, when you square a negative number, you get a positive. 14 squares 196, and you'll get the square root of 200. And the largest square number that goes into 200 is 100. And the square root of 100 is 10. And then you've got your root 2. Okay, so that's quite a long one, that one. Okay, it'll take you a wee while to work that one out. Again, pause the video if you need to get that down. Okay, number 4. It's the same idea again, but it's 3-dimensional this time. So position vector C is going to be minus 5, 4 and 2. And position vector for D, minus 2, 3 and 8. Okay, so it says find the magnitude for C to D. I don't know what CD is yet, so I'm going to work that out first. Remember, take the second letter and subtract the first letter there, okay? So it goes minus 2, 3 and 8, take away minus 5, 4 and 2. Okay, so first what I'm going to do is minus 2, take away minus 5. So that's minus 2 plus 5, so that's going to make 3. Next one along, 3 take away 4. 3 take away 4 is minus 1. And the bit on the bottom, 8 take away 2 is 6 for that one there. So that means I'm well on the way now to work out my magnitude. Okay, square the 3, square the minus 1 and square the 6 and add them together. 9, 1 and 36. What does that make? 46. Okay, and I don't think there's a square number goes into 46, so that's the end of that one. Again, pause it because I'll need to rub that out to do the last one, okay? Okay, last question that we've got here. We have to work out what x plus y would be before we go on to get the magnitude for x plus y. So what's x? 6, 3 minus 2. Add minus 1, 2 and 4. Okay, so 6 plus minus 1, that's the same as 6 take away 1. Next one, 3 plus 2 is 5. And last one, minus 2 plus 4, that's going to come out as 2, isn't it? So to get the magnitude, square root, square the 3 numbers, add them together. Okay, 25, 25 and 4. So that comes out at root 54. Okay, so I've just had a wee think about what square number goes into 54. 9. 9 times 6. The square root of 9 is 3, and I don't know what the square root of 6 is. So that's that one finished, okay? That's the end of that slide. I think the next one you'll be doing some questions yourself. Okay, so here's 6 questions for you to try. So pause the video and have a go at those, please. Okay, here's an old SQA exam question for you to try now. So again, pause the video and work this one out. The answers will come later on. And one more question for today. Again, another past SQA question for you to try here. Pause the video, and again, answers will come later. Okay, so I've started to go over the answers here. So I've started to work out the first part for number 1, which is to work out the vector a plus b. Okay, so next line, I've got my square root, I've got my numbers for my vector squared, and I'm going to add all of those together. Okay, so when I've worked that through, I've ended up with the answer of 5. Remember, this is the magnitude for a plus b, and we need those lines down the side there so that we don't need to write out the big long word magnitudes. Okay, so I've started to work out number 2 here by working out vector b plus vector c. Just going to have a wee look, make sure I've done that right. Yeah, I think that's looking fine so far. So next bit, I'm going to do my magnitude. Okay, so I've got each of my numbers from my vector squared there, and I'm going to add those together. Okay, so when you work that through, you should end up with the square root of 81, which gives you an answer of 9. So that's quite nice. That's 2 that have worked out with whole number answers. Okay, on to number 3, and the first thing I'm going to do is start off with working out what a plus c makes. Okay, so I'm just going to check this again. It does make 3 on the top, minus 2 in the middle, and 1 on the bottom. That's it. So I'm going to start to work out my magnitude now. Okay, so I've got my square root, squaring the numbers for my vector, and also adding them together. Okay, that one finishes off at square root of 14, and I can't simplify that one down. Pause now if you need to, because I'm about to rub it out. Okay, so I'm setting this up to do a take away b first. I have to work that out before I do the magnitude again. 1 take away minus 1, that's the same as adding 1. 3 take away 1, and minus 2 take away 5, that makes minus 7, doesn't it? So I can start to work out my magnitude now. So there's my 3 numbers from my vector squared, and they're all sitting within my square root there as well. Just need to pop in the add. Okay, and you can't simplify the square root of 57, so that's the end of number 4. Remember, I'm going to rub it out, so if you want to pause now if you need to. Okay, so with number 5, first thing I need to do is to work out 3a, so that's 3 times vector a, and I need to take away 2 times vector b. Okay, so that's those multiplied out, so I just need to do the takeaway now. 3, 5 and minus 8. Okay, careful not to stop there because the question does say to find the magnitude. There it is, okay. Notice the ones up here had the lines on, but this one here uses the word magnitude, okay. So, go and start that. Okay, so that's me setting this one up here. So I've got each number from my vector squared, and of course, adding for those. So I end up with the square root of 98 for that one there. Okay, so we need to think about what square number goes into 98. 49 goes into 98 twice, where the square root of 49 is 7. And I don't know what the square root of 2 is. Okay, remember, pause it because I've got one more question to do. I'll need to delete it for the room. Okay, so I'm starting number 6 now. I've got to do 2u, which means 2 times u, so I've set that up there. So let's double u. And then we've got to take away the v. Okay, so that's that part of that finished. Notice that the bottom number is 4. 2 take away minus 2. 2 take away minus 2 is 4. Okay, now that question again asks us to find the magnitude, so square bits on the side. So we don't need to write out the word magnitude. And use Pythagoras. Okay, there's my square root. I've got everything squared, and then I'm going to add. Okay, and that one finishes off as the square root of 53 there, which can't be simplified down. Okay, so that's the end of those ones. Right, the exam questions we'll go over next. So similar to the questions that we did before, we actually need to start off by working out u plus v before I can go on to work out the magnitude of u plus v. Okay, so that's those 2 vectors added together there. Again, you've got to be careful of your negative numbers, haven't you? Okay, so 9 minus 1 and minus 4 there, so I can start to work out my magnitude. Okay, so I've got my square root, I've got my numbers from my vector squared there, and I need to add. Okay, so that comes out as square root of 98. I think we had that in the last slide as well, didn't we? 49 times 2. Square root of 49 is 7. Okay, so that one comes out as 7 root 2. Okay, the next slide's got the official marks, so let's have a wee look at that. Okay, here we go. So working out u plus v gives you your first mark. Then starting to work out the magnitude of u plus v and getting your square root of 98 gives you your second mark, and then simplifying gives you your third mark there for that one. Okay, so that's official mark scheme, so it's out of 3 marks. Okay, this one's a little bit trickier. We've got to find our coordinate of B. Now, one thing that you need to be aware of when you're doing a pyramid is that the highest point of the pyramid, that vertex at the top there, is right above the centre of the pyramid. Okay, so when we're working with point A, we have to come along 2 to get point A. Now, vector, point V rather, comes down and it comes along this way. The first number in vector, coordinate V, got vectors in the brain, the first number there is 5. Okay, now that means that this little bit here is 3. Now, because V is in the centre, this means that this bit over here at the other side is also 3. So when I'm trying to get to point B, got there eventually with the right word, I need to come all the way along here before going backwards, okay? So how far is it all the way along here? 2 plus 3 plus 3, all the way along there is going to be 8. Okay, right, now I went along that way first because it had X on it. Okay, so what I'm going to look for now is how far back this goes, because if I can work out how far back this bit goes here, then this bit at the back will be the same length, and that will give me my y coordinate, which I'll need to put in here. Okay, so if we have a look, the second number that you've got here is 2. So when you're trying to get to point V, you go along 5, back 2. So that means if that bit there is 2, that bit there is 2. So when I'm doing point B, I'm going to have to come along 8 and then back 2 plus 2, which is 4. Okay, now the other thing that we've got to do here for B is we've got to say how far up we need to go for B. But we don't have an up number for B, okay, because we don't have to go up at all for it. So that means your last number there is just going to be a 0. So for part A, the coordinates for B are 8, 4 and 0 there. Okay, for part B, calculate the length of the edge AV. I'll just tidy up a sec. There are different ways to work this out, but we've been working on vectors, so I'm going to use our vectors here. Okay, so if I'm trying to get from A to V, that would give me the vector AV there, and I would do V take away A. Okay, so I just need to think, what would the position vector be? It would be 5, 2, 6. Remember, that's how we would get from the origin to the point V. And for A, it would be 2, 0, 0. Okay, so that's what I'm going to use over here in my working out. Okay, so there's my vector for A to V, and when we're finding the length of that vector, that is the magnitude. So I'm going to use Pythagoras. So I've got my square root, I've got my numbers for my vector, each of them squared, remember, add them together. Okay, so when I work along that, I end up with the square root of 49, and I get 7 units for that. Pause it, because I'm going to go on to the next slide, where we look at how the SQA would mark this. Okay, so here, there's just the one mark for getting your coordinate for B, 840. Just one mark. Now, when you come on to the next bit, we get 2 marks for doing our 6 squared, 3 squared and 2 squared. They've done it slightly different to us, haven't they? I see our one. The way that we did it is down here. That's it. Okay, so we did it as a vector, and we then worked out the magnitude of our vector, 3 squared, 2 squared and 6 squared, and we got our answer of 7 that way. The way that they've done it over here, they've done Pythagoras twice. I like to do it with a vector because it's less work. Okay, so it's just something to watch out for, is rather than trying to figure out Pythagoras twice in a 3D shape, it's easier just to do it by vectors. Okay, much quicker way. And that's the end of today's lesson.